students, we will solve the questions based on series and parallel combination. So first category of question can be कि we have to calculate the effective resistance between 2 points. Say for example, first question we have taken कि point A and B. So we have to calculate the effective resistance between point A and B, and 1, 2, 3, 4, 5, 6 resistances are connected. So we say if we have to calculate the resistance between these 2 points, so keep on reducing the circuit from this side, means the opposite side, and keep on coming towards the point A and B. Now assume a current coming from point A and leaving at point B. Say for example, this current is coming. Then you know at this point, say this point we are calling C, and this point we are calling D. So if you say at this point C, the current will have two possible paths, one through R5 and one through R2. So we can say this R5 and the remaining ones, they are there in parallel combination. Now whatever current is coming, the value is not needed, it's coming through 2 ohm. Then the same value will go through R3 and R4 because no other possible path is there. So we say R2, R3 and R4 are there in series combination and their effective value is in parallel to R5. So we calculate कि R dash is R2 plus R3 plus R4 means 10 ohm on substituting the values, and R dash and R5 are in parallel to substitute the values. So net resistance we are taking R double dash because R we take for the final answer. So 1 upon R double dash is 1 upon R dash plus 1 upon R5 means 1 upon 10 plus 1 upon 10. So on solving we get R double dash is 5 ohm. So now you can say that this whatever resistance is there, now C and D, the net resistance between these 2 points is R double dash. So now whatever current is coming from R1, that will go to R double dash and R6. So these 3 resistance R1, R double dash and R6, they are there in series. The net resistance of the circuit will be R1 plus R double dash plus R6. It means 25 ohm. Similarly, one more question we are taking. In this question, the question is saying that we have to calculate the readings of ammeter A1, voltmeter V and ammeter A2. In this circuit, a 10 volt battery is used. In series of that, a 0.6 ohm resistance is there. Then a 2 ohm resistance and 2 more resistance, 4 and 6 are in parallel. So you know whatever current is coming from this battery, so A1 will read the whole value of current. Now when this current come to this point, means the parallel combination of these two, so depending upon the values of resistances, it will divide in 2 parts, I1 and I2. And because these two are connected in parallel, the potential difference will remain the same. So first, to calculate the total value of current, we have to calculate the net resistance of the circuit. So we are having R3 and R4, they are there in parallel. We get 1 upon R dash, their effective resistance is 1 upon 4 plus 1 upon 6. Once you are having a practice, then there is no need to mention this formula and you can directly show the calculation. So we get R dash is 12 upon 5 means 2.4 ohm. Now if you see this 0.6 means R1, this 2 and this effective between these 2 points is there in series. So we get net resistance of the circuit as R1 plus R2 plus R dash. That is 0.6 plus 2 plus 2.4 means 5 ohm. So current in the whole circuit will be by Ohm's law V upon R, that is 2 ampere, and this 2 ampere will be the reading of ammeter A1. Now reading of voltmeter, you can say that voltmeter is connected across the first only one resistance, that is R2. So reading of voltmeter by the Ohm's law will be I into R. It means in this case I into R1, in this case I into R2. So the value will be 2 into 2 means 4 volt. Now for the next point, we are saying total current is 2 ampere, that is dividing in 2 parts. So we have I1 plus I2 is 2, and in parallel the voltage remains the same and voltage is given by Ohm's law. So we are having I1 R4 is equals to I2 into R3. So that's why we are having I1 into 4 is I2 into 6. So we get I1 is 1.5 into I2. Now if you see the diagram carefully, ammeter 2 is connected in series with 6 ohm resistance and the value we have taken is I2. So we have to calculate the value of I2 only, I1 is not needed. So substitute the values accordingly in the equation in order to reduce the number of steps. So we have 1.5 I2 plus I2 is 2 because total current is 2. So on solving we get 0.8 ampere. The reading of ammeter A2 is 0.8 ampere. Now one more question was asked, that was कि 3 resistance of 6 ohm were given and they were saying कि how will you connect them in series or parallel, that is up to you, whether 2 are in series or 2 in parallel and 1 in series, that way, so that the effective resistance is 9 ohm in first part and second part 4 ohm, and you have to verify this result by showing the calculation. Now if you see the overall values, 6 3s are 18. It means if we connect all the 3 in series, the value should be 18 ohm, but here we want the value as 9. If we take only the one, all the 3 in parallel, so 6, 6, 6, 3, so it means effective resistance will be 2. So in this case, we have to connect 2 resistance in parallel and 1 in series, because value has to be more than 6 but less than 12. So we have taken 2 resistance in parallel, 6 ohm, and 1 in series, and by calculation we are showing 6 and 6 parallel means 3 ohm is the effective resistance and R1 plus R dash is 9 ohm. Similarly, for 4 ohm, you know value of 3 effective resistance. If we are having like 6 in parallel, the value will be 2, and we need the value more than 2 means 4 ohm. That's why we are taking 2 in series and 1 in parallel. The value wise 6 and 6 in series is 12, and 12 and 6 in parallel gives us 4 ohm. The next question is saying that 4 graphs are given in the question, A, B, C and D. A and B are 2 resistances, and they are saying that remaining 2 graphs are there, one for series and one for parallel. So you have to identify which graph is there for series and which graph is there for parallel with proper justification. You know one thing, first we are having I on y-axis and V on x-axis. It means in this case resistance is 1 upon slope of the graph. Secondly, if you see individual resistance, whatever value is there, so net resistance of series is more than the individual resistance, and net resistance of parallel is less than the individual resistance. So that's why we say R is 1 upon slope. So if slope is more, then resistance is lesser. So if you see the diagram, D is having the minimum resistance. So we say D is the parallel combination. And if you see C is having the maximum resistance, so C is the series combination. And last, we are taking effective resistance. We have to calculate, say for example, between A and B. So if you see the diagram carefully, this is 5 ohm, 5 ohm, 5 ohm, 5 ohm. But between these 2 points, means for this point, where the 5 ohm last one is connected, we are having a connecting wire. So if you see the diagram carefully, if 2 possible paths are there in parallel combination, one is connecting wire means 0 resistance, other one is 5 ohm, then whole current will flow through the connecting wire. It means now this 5 ohm resistance will be ineffective as if it is not there in the circuit. So this 5 ohm and this 5 ohm are in series and their combination is in parallel to 5. So we get the value 1 upon 10 plus 1 upon 5. On solving, net resistance is 3.33 ohm. That's all for the day. Take care and bye.